So, ayun na. Another video lang naman ng science. So, for today, ang ating discussion will be mirrors at lenses. But first, syempre, shoutouts muna sa mga taong yan, sa mga taong to. Alright, let's go! How can we know if the image formed is a virtual image? Okay, so what I have here is a convex mirror. A convex mirror only produces virtual images. So you can observe the image formed on the mirror is in upright position, which tells us that this mirror creates virtual images. No? How can we know if the image is real? Real images are only formed by concave mirrors. As you can see, the image produced by a concave mirror is inverted or upside down, which tells us that it produces real images. What I have here is a sample problem for convex lenses. Okay, so as you can see, I already drew the principal axis, the vertical line, and the curves to represent the convex lens. Okay, in this problem, what we have is the object position, which is 9 centimeters, the object height, which is 4.2 centimeters, and the focal length, which is 1.7 centimeters. Okay, I will demonstrate how to draw a diagram for convex lenses. So it must first start with our object, which should be placed in the principal axis. Okay, so according to our problem, it is 9.0 centimeters away from our convex lens. So let's try to measure this one. Okay, so 9, and the object stands at 4.2 centimeters. So let's try to draw this one. 4.2 centimeters. Alright. Okay. So this one is our object. Okay. The focal length, however, is 1.7 centimeters. We have learned that when it comes to convex lenses, there is a focal point before the lens and behind the lens. So let's try to locate this one. So we start measuring from the curve. So we have to measure 1.7 centimeters from the curve to the focal point. So there you go, 1.7 centimeters. So this one is our focal point. Alright, and of course, same measurement from the curve to the focal point. We also have to measure 1.7 centimeters. Okay, so 1.7, this one is our second focal point. Alright, it's time for us now to draw the two rays to represent the light which are refracted by the lens. So it must start from the tip of the object hitting the curve of the lens. Okay, so from the tip of the object straight to the curve of the lens. Alright. So remember, we should stop at the curve of the lens, not on the vertical line. Right? So this is our ray number 1, incident ray number 1. So let me label this down. Incident ray number 1. Okay? Straight line from the tip of the object hitting the convex lens. So from this point in which the light hits the convex lens, we will have to draw the refracted ray. The refracted ray must cross the second focal point. So let's write this line down. Okay. So this is our refracted ray number 1. So let me label this down. Refracted ray number 1. Alright. So basically these two lines are our ray number 1. Okay? Just like in the mirrors, we have two rays in our convex lenses. For our convex lenses. So it's time for us to draw the second ray. Starting from the tip of the object, it must first cross the focal point, then hitting the curve of the lens. So let's write it down. Let's draw incident ray number 2. Tip of the object, crossing the focal point, hitting the lens. Oops. Alright. Perfect. Tip of the object, focal point, lens. Again, we stop at the curve of our convex lens. From this point, just like the ray number 2, for our mirrors, we'll have to draw a straight line, which is parallel to our principal axis. Okay, so straight line. Okay, good. This is our ray number 2. This one is incident ray 2. This one, the straight line, is refracted ray. Refracted ray number 2. Okay. The point of intersection between these two refracted rays is where our image will form. So in this point, okay, so we have to draw a line to represent the image, okay, from this point up to the principal axis. So I hope you find the video helpful, and of course, good luck sa exams. Plus, final shoutouts to the following people. Shoutouts muna. Bati-bati tayo dyan. And of course, kay Laydo.
Power!